Okay, now let's look at task B. Task B wants to show me 3 transformations and have me figure out which of these 3 would not go through the given point. Okay, so let's take a look. If I take f of x and I move it up 5 units, would it go through this point? Well, let's see. Is there a point down 5? That when this guy gets up and walks up 5, it will fall right there? Yes, there is. So that's not the correct answer. We want the one that does not go through. Okay, this one says left 1. So let's see what's happening. Is there a point to the right that will fall on this point when we go to the left? Yes, there is. So not that one. Okay, how about a vertical reflection? If I flip this up, this vertex that's now at -5 will flip up to +5. And this point over here at -4 will flip up to +4. And this point will flip here. And this point will flip here. Every point, I'm just flipping it over this axis just to get an idea of the shape. You don't really need to be this exact. I'm just being extra exact for the sake of the video. The point is that it doesn't go through there. Okay, so you don't have to be this perfect, but just enough to see that when this thing flips, it's not wide enough to go through that point. So that's the one that does not go through. Okay, here we go. Here, if we go left 6, let's see what's happening. So, oh, I think that's our guy, right? Like if I pick this up and I move it to the left, like it's already too far left. So that's got to be the answer. Let's see. Right 6. 1, 2, 3, 4, 5, 6. Yep, that one goes through. And horizontal flip or reflection. Flip this guy. He's 3 away. He'll flip 3 away and become the V shape over here. Definitely A doesn't go through. Okay. Let's see. What if we were to go to the left 2 and down 4? Okay. Left 2, down 1, 2, 3, 4. This right here would be right there. So that one does go through. What if we did a horizontal reflection? That's what we would have. And then we would not go through, okay? But if we did a horizontal reflection followed by a vertical reflection, we would flip here first and then flip here and look like that. Too wide, but you get it. It would go through. Okay. Let's take a look at the next task. This is task C. They want me to complete this so that f is an even function. Even function, you'll remember, is when you flip something horizontally and it's the exact same thing it was. The most classic example of it is that guy, okay? Which is what we've got here. Okay, so that means that if I flip this 1, 1, then -1 should also be 1, okay? So basically, every opposite x value should have the same y value. 2 and -2, 3 and -3, same. This is going to look like that, okay? Perfectly symmetrical. I should be more exact with the points. I'm just getting worried about making this video too long, and nobody likes a long video. Actually, I wasn't so far off with the accuracy. So, okay, cool. That's that one. This is f of x, please note. All right, now we're going to look at g of x. g of x is odd, okay? That means, real quick, let's go back, sorry. With the even function, if we reflect horizontally and ends up being what it originally was, that means that the original equation, the original function, f of x, has to be the same as that function with a horizontal shift. Reflection, horizontal reflection. So that's kind of the formula for even functions. Over here, odd function. Odd function says, I want the original to be the same as if I were to flip it horizontally, boop, 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 and then vertically, boop, right here, boop, boop, it falls right onto itself, you can see. Okay, this is the most classic example given of an odd function. All right, there are lots of odd functions, but this is the most classic one. So we want the original f of x to be the same as that function when it is flipped horizontally and vertically. This is kind of the formula for odd function, the definition. Okay, so what does this mean? This means that every opposite x value has opposite y values. You see? This was the one we did in that activity where you could use these points in the table to complete it, but you just have to take the opposite of what they were. So 1, 1, negative 1, negative 1. 2, 3, negative 2, negative 3. 3, 7, negative 3, negative 7. Okay, and it would look like 2, 3. It would look like that. Okay, so that's these guys. Note, note that this is g of x. So for our particular one, not that this statement, it still represents odd functions, except I should have called it g instead of f, just because this function is g. Okay, so now let's go see if we can answer these questions at the bottom, okay, using the same f and g that we had previously. All the true statements, okay? So this one, f of x equals f of negative x, it does, all right? This function is the same as when you flip it horizontally. That's what that statement says. And actually, we made the function so that this would be true. So that one is definitely true. For B, is f of x the same as negative f of x? Meaning if I were to take f of x, which was this U shape, and flip it vertically, would it be the same? Absolutely not. It would not be the same. This one says that if you take g of x, which looked like this, that's the same as f of x upside down. No, absolutely not. This one says that g of x is the same as g of x if flipped horizontally then vertically. So let's see. Here's g of x. Let's flip it horizontally. And then let's flip it vertically. Yeah, they are the same, okay? As a matter of fact, we made the rest of g of x to specifically satisfy that requirement to make it an odd function. That one's true. And last but not least, is g of x the same as g of x with a vertical reflection? So g of x, vertical reflection. Just this part down, this part up. And no, they're not the same. They're not the same. Only A and D are true.